Hello, folks. Today we have a very wonderful show to talk about on sequencing here. Welcome to the wonderful world of random sequencing, and we have a new name now. Uh, Sequencing random numbers. That is the new website, the new channel that I have, and it's basically the investigation of random numbers and the sequencing that it entails. Now, as you can see right here, this is basically about 120 spins on a roulette wheel, and we're only going to cover just a little section of this, and this is where it all begins here. And the sequences are basically 6 per row here. It starts off with the 9, goes to the right, 12, 30, and then goes on and on and on and on. So when you go to a roulette wheel and you're sitting down and you're wondering what numbers to play, you have to have a knowledge of what numbers are and how they are related. In this case, we have a 9. Now, the 9 could be 3 plus 3 plus 3 plus 3. That makes 9, but sometimes these numbers create a larger number, like 29. A 29, in this case, you could see how the 9 sequenced here. And then it's sequenced to a 12. Now, what is the relationship between 9 and 12? That already forms what we call a soft 29. So you already know that you're going to be playing in an environment or a theme environment of 29. So what is that environment? So the 29, this is the sequence here. Here's the 9 and the 12, right? So if you were to look at it this way, what you have on the right-hand side is the 29. And then on the left-hand side is the 1. And that's just basically an I statement. I what? 29. And that is equal to 29. And I call this a soft 29. So this is already a theme that's going to be playing out. It could be playing out over here, or it could be playing out over here. So on this next sequence, we got a 30. Now, the 30 is equal to a 35. It could be equal to a 215s. So you got to be thinking, what is 30 related to? If it links to a 5, it's linked to 35. If it links to a 15, in other words, 2 15s, 15 plus 15 is equal to 30. So this is what you have to be thinking. And then so it's kind of hard to tell at the very beginning, because you need a certain number of sequences to play out in order to see what environments are going to be playing out, and they happen. They're not just one. There's not just one number that's going to be played out. There are multiple numbers that play out, and those are themes that are played out. So this now, the 30 sequence to a 9. Now, the thing about, okay, so let's go, let me explain first of all the 29, but let's go back to the 29 here. I don't want to get ahead of myself here. But these are ways to make 29. It's good to have a good knowledge of the ways you could form a 29. Now, this is one way. And you could do it also with a 32 linking to a 33. And the way that the way it's done is 3 plus 3 plus 3 is equal to 9, linked to a 2, that makes 29. You could also do it with a 32. A 32 linking to a 33, it also forms 29. 29. And that is 3 plus 3 plus 3 is 9, linked to a 2, that's 29. So that's so whenever you have like a 33, if it's going to be producing a 29, there's two numbers that could do it, either the 32 or the 23. So that's good to know. As you can see right here, you have a 32 and it linked to a 33. So why did it do that? Because that's the theme. Because you have a 29 right here, and it's sequenced to an 18. In other words, the reason why 29 is so important is because it does sequence to an 18. It's all relational. So if you produce a 29, you know it's going to create an 18. And so, if you see an 8 right there, then you say, all I have to do is link it to a 1, like it did right here, and it'll create 18. Or it could be a 10 too. So obviously you would have to make that. That's two options. You would put a 10 there to make 18, or you would put a 1. So you should know this. So anyway, this is 18, and then it's sequenced to a 29. So how did it create a 29? By using a 32. So that's kind of a red flag. It's alarm bells are ringing. You got a 32, and in other words, this theme is playing out 29, right? And so you played out 18. Well, there's an 8 right there, and you get a 32. So the themes. This theme is already being created. Because you haven't quite spelled out 18 here, right? But it did. Eventually, you're going to get to this point where you're going to have to make that decision, because it didn't produce 18 over here. But so at this point, this is a half step away, and so you got to make a decision. You say, well, it's going to produce an 18, and so is it going to be a 1 or is it going to be a 10? So you have to play those two numbers, of course, right? And then, knowing that this theme is being played out, so you have to, knowing that you have a 32, and now you know that a 32 linking to a 33 is going to make a 29. So this theme continues on and on and on. So anyway, so let's go. Let me explain over here. This is this sequence here. This is the 9-10 sequence, right? So is that a 29? It could be a 29. Why? Because because a 10 in binary notation is a 2 also. So you're looking either at a 19, like right here. This is 19, or it could be a 29. Because a 1-0 in binary notation is 29. In this case, it is a 29. Why? Because as you can see right here, you have a 1, and that 1 links to a 00, which is this 00 is an 8. This is what you call a metamorphic 8. It's a lying down 8. So 1 linked to an 8 makes 18. So this number here is 29. 29 because of the 1-0 being a 2 linked to a 9. And so this is you can see how everything is like a half step here, and then the half step over here. Once you see the 1, you know that 1's going to be linking to an 8. Now obviously there are two forms of 8. There's the natural 8, the number we're very familiar with, and then there's the laying down 8. This is a metamorphic 8. So those are two numbers that you're going to have to play out. And as you can see, it's all within a half step. There's a half step here, half step. So it's well connected here, So and then this 18, link sequence to this 18. So it just kind of recreated itself right here, and then it plays out a 29. Now the way it does that is this is what you call kind of a metamorphic 29. And this is the way it looks. So you have the 00s right here, 00 here, and then the 1-1, right? And so if you link the 1 to a 0, that is a 9. Over here again, on the left-hand side, you have 1 linking to a 0, and that is 9. And so that makes 9. What is 9 plus 9? It's equal to 18. And 18 is equal to 29. So this 18 and 18 had to play out a 29 of some sort. So the moment it played out the 00, now that you're very familiar with this concept here, you could use the 11 as an option that it's going to play out. Um, so that's something that you should be very familiar with, that the double zeros, 1, 1, can play out a 9, 9, which is 18, right? And 18 is equal to 29. Because 29 carries this concept, two nines, and 9 plus 9 is equal to 18. So 18 is equal to 29. That's a very important sequence. And again, um, uh, I would say that a lot of times, the 29 sequence is a very, very powerful sequence. It does play out a lot. And so it's good. It's good to know how to approach it. In other words, you know that this is going to be creating an 18. So obviously, you got an 8 there. So you kind of have to wait patiently, because this 8 is eventually going to link a half step away. Half step away to form 18. So it could produce here, but it did it here. So you got to be a little patient and. Use your logic and use your common sense, and you'll do okay here. Same thing with this. This is playing out 29 here. This is 29, and it links to a 1. So now you know that it's going to play out an 8 of some sort. Now, in other words, there's two ways you could play out an 8: natural 8 right here, that makes 18, or metamorphic 8, and that's the 8 that's lying down. All right, so let's go down to another concept here. Now, this is the 30. Whenever you see a 30, you have to know what is the 30 related to, right? So obviously, 15 plus 15 is equal to 30. So that's something that you should know. So because this is what happened. In other words, knowing that 30 is related to 15 plus 15, right? So that would be an option to play right here. In other words, you're playing options. So a half step away. This is a half step. You're assuming, well, quite possibly it's going to be playing out a 15, right? Because it's going to produce 15 plus 15. That would be a nice assumption. Now, in that case, you see 2 times 15 is 30. So in that case, go ahead and play out. Now, I would say, because you don't want to put all your eggs in one basket and say, it's going to be a 15. You want to play out all 5s. In other words, 5, 15, 25, and 35. If you did that, you're going to hit on one of those 5s. In this case, it would be 15. And so now you know that the 15 is being played out. Now, is it going to create another 15? It's a possibility, right? Or is it going to create a 2 to symbolize 2 15s? Now, 2 15s, obviously, it's like saying 2 times 15 is 30. That is a possibility too, So you have to take that into consideration. Is it going to play out a 15-15? Quite possibly. Or is it going to play out a 2-15? And for one thing is that, since you know that this environment, the 29 environment, is still playing out, you have a 9 there, so it's quite possible that it might sequence to 2. So you have to take that in consideration, because if you do put a 2 there, then you got 2 15s, and that's equal to 30, right? And then this 2 linked to a 9 is basically playing out the 29 environment, which is 29 is equal to 18. See right here? 18, 18. And then this is 29. Over here you have 18, 29. So you kind of have to. There are a lot of environments or themes that are being played out simultaneously. All right. So one thing to also note that this 10 right here, you can see 10 is equal to 25, right? The way that is because the 25 carries the statement 2 5s or 5 5. So 5 plus 5, right? 5 plus 5 is equal to 10. So this 10 is a natural 10. and it's related to a 25. Now, by putting a 15 there, it does answer to that sequence, because, in other words, like right here, here's the 12 and 15, right? On the right hand side, you have basically a statement. In this case, the 1 1 in binary notation, that's basically the 11, right? 11 is the equal statement. It's like in mathematics, equals something. What is it equal? 25. So this is a statement of what the values numbers are on the right hand side when it comes to double digits and two cells interpretation. So on the right hand side you have 25. So 25, so 10 is equal to 25. And then what happens is that it sequenced to 2, and then it's sequenced to a 5 to make 25. So this sequence gets satisfied not only here. This is what we call kind of a soft 25. It's not a solid 25 like this is, although this is kind of an extended 25, but still this theme is still being played out, and so that's something that you should understand. So let's go on to so the thing is that if you do have that assumption, for instance, that the 25 is going to be played out to this point, obviously, you want to play out all fives, and that would be 5, 15, 25, and 35, and that would you would cover your base right there, your tracks. Let's go on to here. I think I already did. This is only. All right, so let's go on to this concept here. Now we have the 30 plus 9 is equal to 39, right? Now, whenever you get a 39, it could possibly sequence to a 27. Now, why is that? Because 39 carries the concept 3 nines, or 999, and 9 plus 9 plus 9 is equal to 27. So this is why this 27 played out right here. So you got to think logically. Got a 39, it represents 999, 3 nines, right? 3 nines. And you add those 3 nines, you get 27. So that's a logical sequence, and so think about that, think about it logically, and hopefully it'll land there. So at least you would, it's important to at least intuitively and logically, make these decisions here. So now we have the 27, 20 plus 27 equals 54. Now, as you can see right here, these two numbers right here, when you stack them, like for instance, you have the 34 and the 5. If you were to stack these up, on the left-hand side you have a statement, which is basically 3. It just represents whatever this is, and the value of this number is either 45 or 54. But the fact that you got a 27 linked to this sequence here, the 5, 34, that tells you that it's related to a 27 plus 27 sequence. 27 plus 27 is equal to 54, like right here. 27 plus 27 is equal to 54. So this sequence here, because there's a 27, it tells you that you are in that environment. Now, you only got one 27 there, so you're missing another 27, right? So if you look at how this 27 is connected to this 5, half step away, the 27 is connected to this 34, it's a half step away. So this 4 or 34 has to connect to this 27 in a half step away, and this happens to be the last place where it could actually connect. So you're missing a 27, because 27 plus 27 is equal to 54, and so you have that 54 right there. So these double digits are very important. You should. No, it's kind of hard to see 54 this way, but if you stack it up like this, 34, and put a 5 right here, the digits on the right hand side, these are the value digits, and they say either 45 or 54. But since we see a 27, we know that this is actually 54, because we know that 27 plus 27 is equal to 54. So the only thing it was missing was the 27, and it played out right here, half step away, the last place where it can actually connect. So that's what that's the sequence that you should take. And if you wanted to be safe, obviously, you could play all sevens. There are only three numbers that have sevens. That's 7, 17, and 27. So that's no big deal, right? So you could stack on the 27 because that's really what's missing. All right. So now we're going to go on to another concept. This is the 29. 29 is equal to 58. Now here's the 58, right? I think it is, yeah. Okay, so remember I said that this is a 29. You could see it. 2 linked to a 9, 29, right? And so 29 plus 29 is equal to 58. Now you have a 58 right here, right? 58. So knowing that 58 is 29 plus 29, you know that you're missing a 29. Now there are many ways to make a 29. You can make it with a 30. Excuse me. You can make it with a 32. 32 linked to a 33. That makes 29. In other words, you got 3, 3, 3. That's a 9 linked to a 2. That's 29. So, and then you have right here 58. So you know that you're missing another 29. But knowing that the 32 can create a 29, so you have to think that this is going to sequence to 33, and you would be right on that. So let's go on to I think I already explained this. Now in a 29 environment, it links to 18, right? So over here you have a 1, and this is the laying down 8, and then it goes to another 18 here. And so what happens is it can't just create 18, 18, 18. It has to sequence to a 29 eventually. And this is another way how you could create a 29. And the way you could do another 29 is with the double zeros. The double zeros linking to 1, 1, as you can see right here, makes a 29. This is a 1 linking to a 9. 1 linking to 0 makes a 9. A 1 linked to a 0, that makes a 9, and that's 9, 9. 9 plus 9 is equal to 18, and it's also equal to 29. Okay, so now here we have the 236. 236 is equal to 72. So whenever you get a statement like this, where you have 2 and then 3 and a 6, that's like saying 2 times 36, and 2 times 36 is 72, and 72 is equal to 27, because there is no, in roulette, if I could find this sequence here, let me see if I can find it, 27, let me see, where is it at, is this it? Sorry about this, I don't see it. Okay, 23, okay, 23, oh, I think this is it. Sorry about that. A 23 linked to a 6, if I could find it, 23 linking to a 6, okay, I think this is it here. I'm sorry about this. So so in other words, we got 236. Okay, what is 236? 2 times 36 is equal to 72, right? So 72, there is no cell single cell that makes 72. In roulette, the highest number you can get is 36. So in virtual memory, in virtual mode, the 27 represents 72. So in other words, it's represented in kind of in a reverse sequence. But visually we see a 27, but in reverse sequence it creates a 72. So a 236 will sequence to a 27, but in virtual memory it represents a 72. So that's something that you should be familiar with. So let's go on to another one here. We have the 31 is equal to 1, 1. Okay, so this is this sequence right here. Now, the 31 carries the concept of three ones. Three ones is 111, and 111 in binary notation is equal to 7. So this 31 created this 111, right? Because it's three ones. There's 1 1, 2 ones, and 3 ones. So 3 ones is 31, and this 111 in binary notation is equal to 7. So it's sequenced to a 7 right here. So that's the concept of what this could happen. In other words, if you happen to see a 31 and it sequences to a 1, then you could assume that it is going to play out in 11. Now, there are other reasons why it played out in 11, and I'll have to explain that right now, because this 2-1 is 21. Now, the 21 carries the statement 2 ones, right? 2 ones is 1 1, and so we have 2 ones. It creates a 1 1. This is 21 right here. 2 linked to a 1, that's 21, and that is equal to 11. So this is a very, very powerful sequence. It happens a lot in sequencing, and so you should be very familiar with it. The 21 is equal to 11. All right, so let's go on to another one. We have the 37 sequence. Now let me see where that is. 37. Okay, so we have now here you can see a 37 being formed right here. Now, this is a very, very powerful sequence because it will recreate itself in many ways, you know. And so right here, as you can see, the left-hand digits are statements, and then the value state numbers are on the right-hand side, and so it creates a 37. So this sequence right here is creating a 37. Now, when it sequenced to a 1 1, now in binary notation, 1 1 is equal to 3. So it's very possible that this binary 3 will link to a 7. So because this is already kind of the 37 is already being spelled out. So it's quite possible it's going to do that. And it actually did. And then so these themes get, they reiterate themselves, you know, they play out multiple times. So in this case over here, it did land on 33. Now, let me show you how the 37 gets played out. In other words, here's 33 linking to a 7, that's 37, and then you have, like right here, you have the 11 7. That makes 37 because this is a binary 3 linking to a 7. That makes 37. Here's another way of making 37. That's a natural 3 linking to a 7. That makes 37. And then this is what they call a soft version. These are all soft versions of making 37. This is basically the I statement linking to a 37. Right-hand digits are making 37. And then you have the 23 linking to a 7. That makes 37. And the 33 linking to a 7 makes 37. So if you wanted to carry out the same theme, knowing that you have a 7 there, right? And so you're going to say, oh, this theme is going to be playing out again. So the numbers that will create a 37 is obviously going to be 11, right? It's going to be a 3 because you could have a 3 linked to a 7. It's going to be a 13, or 23, or 30, or 33. So basically there are 1, 2, 3, 4, 5. There are 5 numbers that you could play out in this sequence right here where the 33 is, that will play out at 37. So if you know that, you know, and you know that this theme is being repeated and recreated itself in many ways, you know, like it did right here. This is 37, this is 37, and this is 37, right? That's the sequence that when it gets played out, it's good to know how it plays itself out, because that way you could anticipate what numbers to implement. In this case, even on this sequence right here, assuming that it's going to play out another 37, you already know that they're basically 5 numbers that it could use to create that 37. That would be the 11, 3, 13, 23, and 33. You know that you'll be okay. You'll hit those. One of those. In this case, it was the 33. All right. So now we're at this point where the 11 is equal to 16. If I could find that here, and 11. I'm sorry. This number here, the 11 linked to a 0, that makes a 16. And how it does that is that you have a 1, which basically has a value of a 10, linked to a 1, 0. That 1, 0 is a metamorphic 6, and that is equal to 16. And 16 is equal to 28, because the 28 carries the statement 2 8s, which is 8, 8, and 8 plus 8 is equal to 16. Now, if I could find that sequence here, excuse me, let me see if I could find it. 11, oh, the 11, 0. Okay, here it is. So here's the 11 and the 0, and that is 16, right? This is a 1, this is a 10 value, and linked to a 1, 0. That's the metamorphic 6. So we have 16. And this 16 then sequences to a 28, because 28 carries a statement 2 8s, which is 8, 8, and 8 plus 8 is equal to 16. So that's pretty much it. I hope you enjoyed the sequences, and I'll be covering up more roulette, but I think I might be getting into lottery. A lot of people are very interested in lottery, so the sequences are pretty much the same. It's the same logic, same reasoning. And the thing about roulette, I mean the lottery, is that a lot of the sequence reference the calendar date. Now, I'm going to show you how those sequences, even though, you know, on roulette, you know, the days that these sequences occur are already pre-planned. So they write out, like, on such and such day we're going to have another sequence. And so those numbers relate, even though they're kind of forecasting the future, you know, right? Because they set these up in like a calendar, right? And they give them these special numbers, you know, for every little sequence. They have like I don't know what they call them. Every sequence they have this identification sequence number that they put in for each calendar date that they have the sequence, and those are very important, especially the last 2 digits of those sequence numbers that they put in that represents that particular day they're going to be spinning, or, you know, creating these random numbers. So calendar date is very, very important. You know what is also very important, and it's unfortunate they don't give us. They should put down the time. The time sequence is also very important. Even though the time sequence might be short, it's good to know the minute and the second that is involved when those numbers show up, because those are also a part of the sequence. And so some of the gaps that we don't, you know, if you do just sequence based on the calendar dates and whatever numbers are showing up on these sequences, it's good to know the time sequence, because they help to fill in the gap. And so it would be nice if they did that, but I don't know if they're going to do that. So anyway, I hope you enjoyed this sequencing, and we'll catch you on the next random sequencing here. Thank you. Okay, so